Hello everyone, this is Dr. Lennon, and I just want to go over a handful of questions from homework number 3, or homework number 6 rather. So I had a few questions and I wanted to get those. So why don't we go over maybe something like half the problems. So let's start with number 2. I know specifically I received questions about number 3 and number 9, so I know I'll get to those as well. But number 2 here, we're trying to find the first the vertex of this quadratic equation, which looks like f of x equals 2x squared minus 4x minus 4. So we know the vertex, so the vertex formula basically says the x coordinate is at negative b over 2a. So that's what we're using to find the x coordinate. So our x coordinate of our vertex is given by, so b here is negative 4 and a is 2. So we have positive 4 over positive 4, which comes out to 1. To figure out the y coordinate, we go ahead and plug that into the formula. So we get f of 1, which is 2 times 1 squared minus 4 times 1 minus 4. So that comes out to negative 4. So we have our vertex 1 comma 4, we can, or 1 comma negative 4. So we can enter that. And then the x-intercepts, you can kind of see where they're at on the graph, but another way to do it is just set the function equal to 0. So we can say, so for the x-ints, we can set this whole thing equal to 0. So 0 equals 2x squared minus 4x minus 4. You can divide the whole equation by 2 to make the numbers a bit smaller. So this one isn't going to factor, so we'd have to use the quadratic formula here. So x would be positive 2 plus or minus the square root of negative 2 squared minus 4 times 1 times negative 2. So it was a little bit sloppy there. So minus 4 times a, which is 1, times negative 2, with everything being divided by 2 times a. And so we end up with 2 plus or minus the square root of, this is 4 plus 8, so that's 12 over 2. So your x-intercepts, you can actually rewrite this as 2 plus or minus, what is that? That's going to be 2 square root 3 over 2, which if you want simplifies to 1 plus or minus the square root of 3, because everything's divisible by 2 there. So your x-intercepts are actually going to be 1 minus the square root of 3, comma 0, and 1 plus the square root of 3, comma 0. So those are the two intercepts. So 1 minus the square root, does it? Can't remember if the command works. Yeah, it does. 1 minus the square root of 3, and 1 plus the square root of 3. Oh, it wants me to do comma 0 as well, so don't forget that. So 1 plus the square root of 3, comma 0. And then the y-intercept is easy. That's just the minus 4. So that's when you plug 0 in for x, the 2x squared goes away, the minus 4x goes away, and we're just left with the minus 4. So that should be 0. Minus 4, because the parabola opens up, we know that's going to be the minimum value. So that's the minimum value of x. F of x is minus 4. And then the domain and range is going to be all real numbers for the domain because it's a polynomial. So I don't know what the command is for the infinity symbol here. So let's go ahead and find that. Should be under symbols. So there we go. And then we need to do comma to infinity. And the range, we know the smaller of the two values, or the smallest value it can reach is the minimum, which is negative 4, and then it goes all the way up to, again, positive infinity there. And we want a parenthesis with that, I believe. Let's go ahead and submit to make sure we got everything right there. Okay, so okay, so we had some things that are mistakes here. Oh, I did the y-intercept. The minimum value is at the vertex. Sorry, so the vertex. Did I botch up the vertex when I plugged that in? Maybe I did. Oh, so I did 2 squared, not 1 squared. So 2 minus 8 is -6. So this vertex value should be -6. So that's a mistake there. So the vertex value here should be -6, and that's also the minimum value. So the minimum value is -6, which will also change the range from -4 to -6. So if we do that now, everything should come out correct. So again, that's my mistake there. So there we go. Everything's correct now on number 2. Okay, let's have a look at number 3. So for number 3, the first thing it wants is the end behavior. So for number 3 here, we have s of x is 3 over 2 x to the 6th minus 3 times x to the 4th. So the end behavior is, remember, determined by looking at just the leading term. So 3 over 2 is a positive number, and the power is even. So we're positive and even. So that means both sides rise, which, if you want to think about it, the arrows, what are the arrows doing? They're going up somewhere like this. So that means as x goes to -infinity, y goes to infinity, and as x goes to infinity, y will also go to infinity, because if you're going up on both sides, that is the positive infinity direction. Down on both sides would be the negative infinity direction. So we just have to plug infinity in for each one of those. And to figure out the graph, you could either use a graphing calculator or you could look at the intermediate behavior. So we know 3 over 2 x to the 6th minus 3 x to the 4th. What could we do? We could take out that x to the 4th, and we just have 3 over 2 x squared minus 3. So we're going to end up with 3 zeros here. So this can factor, well, depends on how you want to solve it, but probably the easiest way is to pull out the 1.5. So you could factor out the 1.5. Sorry, I meant to go eraser. So instead of 3 over 2, I'm just thinking about it as 1.5. So if I factor out 1.5, I know this is just x squared, and then it would be a -2, right? Because 1.5 times 2 is 3. So then I can factor this into x plus the square root of 2 times x minus the square root of 2. You could have also just set the thing, the quadratic factor equal to 0 and use the quadratic formula, something like that. But basically, remember, we have our 0, our exponent, and the behavior. That's generally how I determine my intermediate behavior here when I'm graphing. So we have 3 zeros. The first part, the x to the 4th, that is 0. Then we have the minus square root of 2 and the plus square root of 2. So 0 has an exponent of 4. Both of these have an exponent of 1. So we know we should bounce off at 0 and cross at the other two. And if you check on your calculator, the square root of 2 is about 1.41, something like that. So basically it's going to bounce off at 0, and it's going to be crossing at around that 1.4 value. So if we're looking at the graphs here, we notice that this one this graph looks like the correct choice because it's bouncing at 0 and it's crossing at both the negative square root of 2 and the positive square root of 2. So that should be our graph. So that's it for number 3, really. Maybe since the numbers weren't nice integers, that might have thrown some people off. But you just have to either rely on the quadratic formula or use difference of squares like I did. So we have both the answers there. Yeah, and we got the check mark, so we got that one right. Okay, 4 is going to be very similar. You have different end behavior, but the same process is going to work. 5, again, very similar. So the next few are quite easy. So why don't we... All of them are already factored, so you know where the zeros are based on the behavior. So for instance, if you look at number 8, we know the zeros are -2, -1, 2, and 3. And then if you multiplied out, your leading term would be x to the 4th power. That's positive and even, so both sides should go up. So both sides should go up, and you should see it crossing at those 4 zeros. -2, -1, 2, and 3. So -2, -1, 2, and 3. This looks like a potential graph, so it looks like it should be choice C. So I would choose that one. Okay, number 9. I know I received a question on that, so let's go over number 9. So we just need to do a synthetic division here. Should be pretty easy. So we have p of x, our polynomial, and then d of x for the divisor. So then our d of x is the divisor. And they want us to write this in kind of a specific form, but that's all we're doing is the division. So the root of d of x is 2, so that goes in the corner, and then we put the numbers for p of x on top, 2, -5, -7. And so bring the 2 down, multiply the 2, you get a 4, add, you get -1, multiply by 2 again, you get -2, and then add, you get -9. So what they're saying is they want us to write it as q of x plus the remainder over the divisor. So remember, this one is your remainder, this is constant, this is your x term, and then the degrees just increase as you keep going to the left. So our answer should look like 2x minus 1, and then you could write this as either -9 over the divisor x minus 2, or you could do plus and -9 on top. Either way, it should work out fine, but really not too much of a problem there. Maybe the form could be a little bit confusing, but really it's just synthetic division as normal, so I don't really see too much of a problem there. And it looks like that's essentially the rest of the questions are along the synthetic division lines. So maybe we'll do 2 of those and then wrap it up. So number 9 we have there. Yeah, and so all of these you can do synthetic division for. So I don't know. Why don't we do, let's say 12. 12 looks tricky, and maybe that'll be it, because they all look pretty simple. 12 I'm choosing because it's missing some terms, so we have to add some zeros in there. But again, we also did plenty of examples in the lecture video for the synthetic division section. So we have x minus 4 here. So let's see. 4 is our divisor, or the root of d of x. And then we have a 1 for x to the 4th, a 2 for the x to the 3rd. We have no x squared term, so I'm going to put a 0. We have a minus 13x, and then we have no constant term, so I'm going to put a 0 there as well. So let's bring this 1 down, take that result multiplied by 4, add those two, we get a 6, multiply 6 by 4, we get 24, add, we get 24 again, multiply 24 with 4, you have 96, 96 minus 13 is 83, 83 times 4 is 332. So that's our remainder. So the way they want us to write this, let's see if we can do it. We would have, so remainder constant, x, x squared, x cubed. So we have x to the third plus 6x squared plus 24x plus 83 plus our remainder 332 over x minus 4. So let's see if this checks out. Oh, here it says express p in the form d of x times q of x plus r of x. So they want this one in a slightly different form. So in this case, we're just going to write, so our polynomial was x to the fourth plus 2x cubed minus 13x. And what we're saying is this is equal to our divisor times our quotient, which is x minus 4 times the quotient. So this whole thing is q of x. And then just the very top here is r of x. So x minus 4 times this guy, x cubed plus 6x squared plus 24x plus 83, and then just plus 332. That's the form they want. So let's see if we can write the answer that way and get it correct. So you do have to watch a little bit on the directions. Sometimes they'll change them up from question to question where they're essentially asking you to do the same task, but the format of the answer is just slightly different. And that's just the way things are. Sometimes there's multiple forms that answers can be given in, and you just have to pay close attention to which one they're asking for. So hopefully that goes okay. Okay, yeah, so we got it correct. So that's good that we caught that. So 11 uses that same format. But then when you look at 13, they just want the quotient and the remainder. But you're still just doing synthetic division. So this is Dr. Lennon signing off.